Hello everyone, hope you all are doing well. In this video, we'll discuss the first problem of Leetcode Weekly Contest 310. It's an easy level problem. The problem name is most frequent even element. So the problem statement says that given an integer array nums, return the most frequent even element. If there is a tie, return the smallest one. If there is no such element, return -1. Nothing fancy in this problem, it's just that how you implement that, because this problem can have multiple solutions. Some solutions can take extra space, some solutions can take extra time. So we'll discuss all that. So yeah, this is the problem statement. Let's jump to the explanation part and see what this is saying. So yeah, if I take the first example, so the given array is 0 1 2 2 4 4 1. So we need to find the most frequent even occurring element, and in case of a tie, return the smallest element. So what are the even elements here? Just remove the odd ones first. Right? These are the odd ones. So 0 occurs one time, 2 occurs two times, 4 occurs two times. So in this, these two numbers are occurring twice. So there is a tie. So you return the number, the smaller number. So we return 2 in this case, right? If I take the second example, so it is 4 4 4 9 2 4, right? So just return the just remove the odd numbers. This is removed. So 2 comes one time, 4 comes 4 times. So my answer will be 4 in this case. And if I take the third example, so again, if if you have numbers like 1 3 21, something like this, so we can see here all the numbers are odd elements. So in this case we return -1. So this is what the problem is saying. Now there can be multiple implementations. One of them could be that you sort this array, right? You sort this array. So now what will happen? Suppose I take the example of this one, right? So suppose I sort it. So what I'll get 2 4 4 4 4, right? I'll get this. Now the benefit of this one will be, the benefit of sorting will be that no extra space will be required. All you can do is you can sort the array. Obviously after removing the odd elements, there can be multiple techniques to remove the element. One could be that what you do whenever you do certain comparisons, you check whether it is even or odd. Or to simplify, you can create a new array having only the even elements. So yeah, there could be multiple approaches. I'm just telling you the main logic. So the main logic will be you sort the elements and you get numbers in sorted order. So what you do here, you basically traverse the array. You take a current variable which tells you what is the current number. So for initially the current number is 2. You also take what is the current frequency, it is 1, and then you take a max number, and then you take a max frequency. What this means is, this is my current number and this is the frequency of the current number. So when I start, my current number is 2, right? Now I start traversing, right? I start traversing, and obviously initially max number will also be 2, because this is the only number that I have encountered till now, and max, the frequency of the number having maximum frequency is also 1, right? So initially it will be 2 1 and 2 1. Now what will happen? You start traversing and you come to 4. You see that 4 is not equal to 2. That means the current number, the ith index, the value at the ith index is not equal to the current number. So what you do, you basically do an updation, that just check whether the frequency of the current number is greater than the max frequency encountered till now or not. In that case, just update that number, and now your current will become 4 and the frequency of the current number will become 1, right? Because this is the first time you have encountered this number, right? You are encountering the number in sorted format. Now you move here, you see that okay, the ith index has the value which is equal to my current number. You increment this frequency, it becomes 2. You move here, you increment the frequency 3. You move here, you increment the frequency to 4, right? Now finally, when you come out of the loop, you just check that what is the maximum frequency and what is the current frequency. Now again, if the maximum frequency, we did that in the first step as well, if the maximum frequency is less than the current frequency, then what we do, we update the maximum frequency and we update the number having the maximum frequency. Now since our numbers are in sorted order, we will only do this updation if the current frequency is greater than the maximum frequency, because in case of a tie, we want to return the number with the smaller magnitude, right? What I mean to say, suppose the numbers are 2 2 and 4 4. So when you come here, the max frequency was 2. That the number having the maximum frequency till now has came 2 times, and the number which has the maximum frequency is 2. This is what you did. Now when you came out of the loop, your current frequency was 2 because of these two fours, and your current number was 4. Now since these numbers are in sorted format 2 and 4, what you do, yeah, this frequency and this frequency is equal, you don't do any updation, and then we just return our answer. This is basically the method using sorting. What I have done is, just for simplicity of the code, I have taken a basically tree map. I have taken a tree map, and in that tree map what I have done, I have inserted the numbers. Let me directly show you the solution, because nothing too complex is there in the solution. The sorting, I have not coded the sorting one, I have coded the one using tree map, because that was the easier one to code, right? No boundary conditions and all. So what I have done on line number 3, you can see I have created a tree map, and from line number 4 to 6, what I have done, I have inserted all the numbers, all the even numbers, and basically with their frequencies, right? So on line number 6, I have used a function map.put nums of I, and if that number is present, then just increment it by 1, else put 1 there, right? So that is done using map.getAllDefault. So yeah, that is an inbuilt Java function, but nothing fancy. Core logic is, I have updated the frequency of all the even numbers. Now as I told you, on line number 9 and 10, I have the maximum frequency, that is -1, and the number having maximum frequency, that is again -1. Now I start traversing my map, and I check that for the current number, what is the frequency of the current number. Now if that is greater than the maximum frequency that I have seen till now, just do the updation. Now again, I have taken a tree map. In tree map, the basically keys are sorted, right? So that means value 2 will be coming first, value 4 will be, not value, basically the element 2 will be coming first, the element 4 will be coming after that, and so on. It doesn't matter what their frequency is, but they will be in sorted order according to key, right? So I'm checking the frequency, and only when the frequency of the current number is greater than the maximum frequency that I've seen till now, I do the updation, and at last at line number 18, I return the maximum frequency. So yeah, these were the two solutions. For the first one that used sorting, since I used sorting, so obviously the time complexity of sorting will be big O of n log n, and obviously the other operations that we were doing were big O of n, so that is why the overall time complexity will be big O of n log n. For this one, the time complexity will be big O of n, because you are traversing the array 2 times. Basically first you are traversing the array, and the second time you are traversing the map. Now obviously the maximum number of elements in a map can be the number of elements in the array, so it will be big O of n plus big O of n, that comes out to be big O of n, right? So yeah, these were the two solutions. I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case you have any queries, do mention that into the comments. I'll try to resolve each one of them. Yeah, take care. Bye bye.